This one. Good evening, children.
Good evening, ma'am.
Good evening, ma'am.
Good evening, ma'am.
Good evening, children. Yes, take down this question. Which of the following are algebraic expressions? So last class, we understood the different types of polynomials. We understood the different types of polynomials based on, classified based on the degree of the polynomial and the number of terms in the polynomial. So today we'll be answering some questions related to what we understood in the last class and the class before that. Yeah, which of the following are algebraic expressions? Write down all the options, children, and keep your answer ready. Can I have the answer for the first one?
Ma'am, it's F, ma'am. All
F.
of A.
All of A, B, C, D.
C and D.
It's F. All of A,
A,
B,
B.
C, and D. All of you?
Yes, ma'am. Yes.
Yes, ma'am.
Okay. So there is no condition for an an expression to be an algebraic expression. Anything made up of constants and variables. If you see some constants, variables connected by the mathematical operations, plus, minus, multiplication, or division, it's an algebraic expression. You don't have to look at the powers. There is nothing basically to decide. So all these, A is an algebraic expression, x to the power 7 is an algebraic expression. The option in B is also an algebraic expression. The power of x is 1 by 2. It's root x. Root x meaning x to the power 1 by 2. That's okay. 4 root x plus y cubed. The power of x, the powers of the variables involved can be anything. So though it is not a whole number, as it should be in the case of polynomials. These are algebraic expressions. The option in C also is an algebraic expression. D also is an algebraic expression. So the correct option is F, all of A, B, C, and D. All of A, B, C, and D. All these expressions in A, B, C, and D are algebraic expressions. This is the next one. Which of the following are, okay, so here among these options, which are polynomials? Among the options here in the first one, which are polynomials? Is x to the power 7 a polynomial?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. What do you call it based on the number of terms?
Monomial.
Monomial.
It's a monomial. It's a monomial. X to the power 7 is a monomial. What do you call it in terms of the degree of the polynomial? In terms of degree? What's the degree of x to the power 7?
7, ma'am.
7,
The
ma'am.
degree is 7. Yeah. It's a polynomial in one variable of degree 7. X to the power 7 is a polynomial in one variable. Is a polynomial in one variable x. X to the power 7 is a polynomial in one variable x of degree 7. Based on degree, the degree is 7. Based on the number of terms, it's a monomial. It's a monomial. It is a polynomial because the power of the variable x is a whole number. That's all. Simple. The power of the variable x is a whole number. So it is a polynomial. Is the expression in B a polynomial? Is the expression in B a polynomial?
No, ma'am.
Why?
A variable cannot have a root in its power. That gives x power 1 by 2.
Yeah. So in option B, 4 root x plus y to the power 3 is nothing but 4x to the power 1 by 2 plus y to the power 3. Root x, when you express this in the exponential form, it is x to the power 1 by 2. This is the radical form. When you put this in the exponential form, x to the power 1 by 2. This is not a whole number, not a whole number. The power of x is not a whole number. X is a variable. X and y are the variables. X and y are the variables. Here, the power of the variable y is 3. This is a whole number. This is a whole number. This is fine. But here in this term, the power of x is not a whole number. This one is not a whole number. And hence, the expression in option B is an algebraic expression, but not a polynomial. Because if it should be a polynomial, the powers of all the variables in the expression, must be whole numbers. What about the option in C? What about the option in C? Is this one a polynomial?
No, ma'am.
Because how many variables can you see here? How many variables can you see?
3 variables.
3 variables. You can see 3 variables, A, B, and C. What's the power of A?
3, ma'am.
3, ma'am.
3. What's the power of B?
1, ma'am.
And what's the power of C?
1 by 2.
1 by 2. Root C meaning C to the power 1 by 2. So the power of the variable C is not a whole number. So this one is an algebraic expression. This expression is an algebraic expression, but not a polynomial. What about D? Is it a polynomial?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Yes. The expression in D is a polynomial. Because the power of the variable x here is 3, whole number. The power of the variable x again here is 1, which is a whole number. Y, 1, it's a whole number. The powers are all whole numbers. The powers of the variables involved are all whole numbers. x variable power 3 whole number, x variable power 1 whole number, y variable power 1 whole number. The variables involved have whole numbers as powers. So this expression is a polynomial. It is an algebraic expression. It's also a polynomial. It's a binomial because two terms. It's a binomial. It's a binomial. And based on degree, it's a cubic polynomial. It's a cubic polynomial because the highest power is 3. The highest power is 3. So here the power in this term, the power of the variable is 3. This term has two variables. So the power of each of the variables is 1. So 1 plus 1, 2. 1 here, 1 here. So find the sum of the powers of the variables in the second term, because the second term has two variables. The second term has two variables. Power of x 1, power of y 1. Add 1 plus 1 2. Here there's only one variable, x power 3. Highest value 3. So degree is 3. So if the degree is 3, it's a polynomial of degree 3. And which we know is a cubic polynomial. It's called a cubic polynomial. In two variables, x and y. There are two variables, x and y. Yeah, this is the second one. Which of the following are polynomials? Please write down all the options first. Please write down all the options first. Which of the following are polynomials?
And 1 minute, can you show me the first slide?
Yeah.
Yes, ma'am. Thank you.
Yeah. Yes, children. Yeah, which of the following are polynomials? The first one, is it a polynomial? The first expression, is it a polynomial?
No, ma'am.
No, ma'am.
No, ma'am.
All of you?
No, ma'am, it's not a polynomial.
Not a polynomial.
Not a polynomial.
Okay. Fine. So let's just try to work that. The given expression in A is 3 fifth root of 3 into 3 and there's no sign. So 3 into fifth root of x to the power 18 divided by fifth root of x cubed. So this, so before, we conclude if it is a polynomial or not, we need to simplify if possible. If simplification is possible, we need to first simplify and then conclude. So just by looking at this, you cannot say it's a polynomial or not. So if possible, simplify. So look here, 3 into fifth root of x to the power 18 can be written as x to the power 18 by 5. Is this right? Because fifth root of x to the power 18, this is nothing but x to the power 18, fifth root. So it is into 1 by 5. It's into 1 by 5, fifth root, right? So it's into 1 by 5. So which means it's x to the power 18 by 5. 18 into 1, 18, 18 by 5. Divided by fifth root of x cubed. So this is nothing but x cubed into 1 by 5, fifth root. Meaning the power should be multiplied by 1 by 5. So this is nothing but x to the power 3 by 5. 3 by 5. So x to the power 3 by 5. So the numerator is 3 into x to the power 18 by 5. The denominator is x to the power 3 by 5. Now, we know by the law of exponents, when bases are same and its division, you have to subtract the powers. So x to the power 18 by 5 minus 3 by 5. When bases are same, x, it's division because one x is in the numerator, the other one is in the denominator. So they are in division. When bases are same and its division, subtract the powers. So x to the power 18 by 5 minus 3 by 5. So this is 3 into x to the power LCM. So 18 minus 3 is 15. 15 by 5. 15 by 5, which is nothing but 3 x to the power 15 by 5 is 3. 3x cubed. So the expression in A simplifies to 3x cubed. Is it a polynomial or not?
It's a polynomial, ma'am.
It is. It is a polynomial. It is a polynomial. It is a polynomial. Let's work it again. Let's work it again. See here. 3 into fifth root of x to the power 18 divided by fifth root of x cubed is equal to 3 into, let's write it in the exponential form. So it will be x to the power 18 by 5. I told you x to the power 18, fifth root, meaning the power is multiplied by 1 by 5. So x to the power 18 by 5 divided by x to the power 3 by 5. X cubed into 1 by 5. Now bases are same, it's division, so we subtract the powers. 18 by 5 minus 3 by 5. So it is 3 into x to the power 18 minus 3 is 15, 15 by 5. 15 by 5 is 3, which is 3x cubed. 3x cubed. So the first one is a polynomial. And the question is, which of the following are polynomials? So there can be more than one polynomial here. Which of the following are polynomials? So the first one is a polynomial. What about the second one, children? Is it a polynomial, the second one? The second expression, is it a polynomial or not?
Not a
Look,
polynomial, ma'am.
It's not polynomial.
so Danya, you say it's not a polynomial. Tell me the variable involved in the expression.
X is the only one variable, ma'am.
What's the power of the variable?
2, ma'am.
Is it a whole number?
Yes, ma'am, it's a whole number.
Then it is a polynomial. You should not worry about root 7, the coefficient. This is a constant. This is a constant. There can be anything. We are concerned only about the powers of the variables. We are not concerned about anything else. We are not concerned about coefficients. We are not concerned about constants. We are only going to look for the variables. We are only going to look for the variables. In the second expression, that is the expression in B. In the expression in B, this is a constant. So we are not checking at this. It's a constant. Leave that. This is the coefficient. Remove it. This is the variable. Its power is 2. It is a whole number. It is a polynomial. That's all. Take away those which you're not concerned about. You're not concerned about certain things in the expression. Take away all that. We are not concerned about the coefficient. We are not concerned about this constant. We are only concerned about the variable. So when there is a variable, we check the power of the variable. It's 2. It is a whole number. So this expression is a polynomial. It is an algebraic expression. It is also a polynomial. That's how we decide. Is it fine with all of us?
Yes, ma'am.
Yes, ma'am.
Yeah. So here simplification is not possible. You cannot simplify anything here. So we straight away look at the power or the powers of the variables involved. Here simplification is possible. So we simplify and then we conclude. Here nothing. In B we can't simplify. So straight away take away this, take away this. This is the variable. Power is a whole number. It's a polynomial. Please write down the working, children, for A. Write on the working for A. How we simplify A, write down.
Completed, ma'am.
Yeah. Completed now. So
1 minute,
now
ma'am.
so far,
1 minute,
yeah.
1 minute, wait, wait.
1 minute, ma'am.
1 minute, ma'am.
Okay. Yeah. So far, what have we concluded? A is a polynomial. B is also a polynomial. Now let's look at C. C. Is simplification possible in C?
No, ma'am.
Class, can we simplify the expression in C?
Yes, ma'am.
Can we simplify the expression in C? Yes or no, children?
Ma'am, I think we can do it, ma'am.
We can.
Ma'am.
Okay, Devadarshini says we can. What about Sindhu? We can. Okay. Yes, Devadarshini, you can try first. How do you simplify?
Ma'am, 1 second.
Yeah.
Ma'am, in the variables x to the power 6, y to the power 4, z to the power 10, we can cancel with 2 table, ma'am.
Cannot simplify. Maybe.
Ma'am, you can irrationalize the 4 by root 7, ma'am.
Rajat?
Ma'am, we can rationalize the 4 by root 7 fraction, ma'am.
Oh, that's a constant. We are only concerned about the variables. We are not, this constant is not going to decide. 4 by root 7 is a constant, and that is not going to decide if the expression is a polynomial or not. Only the powers of the variables are going to decide.
Yes, ma'am.
So you don't have to okay, because I said simplify, maybe, you got to understand that you have to simplify the denominator, rationalize the denominator here. No. That we don't have to do. It's a constant. It's a constant, and even if you rationalize, that is not going to decide if the expression is a polynomial or not. The variables are here, x, y, and z. So we are only concerned about the powers of the variables there, if
Yes,
their whole numbers are not. Yes,
Ma'am,
Sindhu? Yes,
Ma'am?
Sindhu? Yeah. Yes, children, quickly.
Ma'am, can I
Ma'am?
try?
The power 6 into 1 by 2, ma'am. And y to the power 4 into 1 by 2 and z to the power 10 into 1 by 2, ma'am.
Correct. Yeah. So you can simplify like this. Let me show you in the answer slide. So I've not written the step there. So now we know that, when you remove the square root symbol, you need to raise the base to the power 1 by 2. Because there is 2 here, I've told you. There is 2 here. When you remove the square root symbol, you need to raise the base to the power 1 by 2. So here it is x to the power 6, y to the power 4, z to the power 10. If you remove the square root symbol, you must raise the entire thing. All these are under the square root. You must raise the entire thing to the power 1 by 2. To the power 1 by 2. Minus 4 by root 7. See, otherwise I'll tell you, you don't have to show so many steps. You can just understand like this. In squares and square roots last year, what did we, recall? What have we understood? Under the square root, how many x's are there? 6 x's. So 3 of them will come out of the square root. Under the square root, there are 4 y's. So 2 y's will come out. And under the square root, there are, 10 z's. Z into Z into Z into Z into Z. Z multiplied with itself 10 times. So it will be Z to the power 5 outside the square root. Minus 4 by root 7. So here when you check the variables and their powers, all the powers are whole numbers, and so the expression in C is a polynomial. I'll show you.
The answer which I said was right only, no, ma'am. Except which I said.
That is what, no, that's what I didn't complete. You said you should divide everything by 1 by 2. That you meant that because 6, 4, and 10 have 2 as a common factor, you should divide, correct?
Yes, ma'am.
That's what, that understanding was incorrect. I was about to say that your answer, the answer which you get from that will be the same, but the way you understood it is incorrect. It's not, we are not dividing by 2 because 6, 4, and 10 have 2 as common, correct?
Yes, ma'am.
So the steps go like this. For C, it's square root of x to the power 6, y to the power 4, z to the power 10, minus 4 by root 7. So to simplify, x to the power 6, y to the power 4, z to the power 10, raised to the power 1 by 2. We remove the square root symbol and raise the whole thing to the power 1 by 2, minus 4 by root 7. So this means it is x to the power 6 into 1 by 2, y to the power 4 into 1 by 2, z to the power 10 into 1 by 2, minus 4 by root 7. I'll continue here. So when you cancel out 2 and 6, you get x to the power 3. Then 2 and 4, y square, z to the power 5, minus 4 by root 7. And here we need to look, so we have simplified now. Now we need to look at the variables x, y, and z. Their powers 3, 2, 5, all whole numbers. So the expression in C is a polynomial.
Ma'am, in this question for B alone, I couldn't understand, ma'am.
In B, so what is the variable there? Devadarshini in B?
X, ma'am.
What is the power of x?
X to the power 2, ma'am.
Yeah, what is the power of x?
2, ma'am.
Is it a whole number?
Yes, ma'am.
So it's a polynomial.
Okay, ma'am.
So the expression is a polynomial.
Okay, ma'am.
Yeah. Children, write on this simplification part for C. So now what is the answer? Which is the correct answer?
D.
All of A, B, C, ma'am. D,
All
option
of
D.
A, B, C. A is a polynomial. A, B, C, all are algebraic expressions. And they're all polynomials. A on simplifying is a polynomial, B is a polynomial, C is also a polynomial. Because everywhere the powers of the variables involved are whole numbers.
Completed, ma'am.
Very good. Done, all of you?
No, ma'am.
Completed, ma'am.
1 minute, ma'am. 1 minute.
Yeah.
Just a minute.
Yes, children, we have to move on. Done?
No, ma'am, just a minute, ma'am. Yes, ma'am, done, ma'am.
All right. Yeah. Which one is a binomial of degree 100? Which one is a binomial of degree 100? Is option A an algebraic expression? Okay, first write down the question, children. Write down all the options, children. Don't write only the correct option. We need all the options. Which one is a binomial of degree 100? Done writing the question?
Yes, ma'am.
Okay. Now tell me, is the first one an algebraic expression? Option A, is it an algebraic expression?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
It's an algebraic expression. Simply, blindly, you can say it's an algebraic expression.
Yes, ma'am.
Okay. Is it a polynomial?
Yes, ma'am.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
It is not a polynomial. The expression in option A is not a polynomial because You need to see it like this. Now, for example, if you have 1, okay, now tell me if 1 by x, tell me if is 1 by x an algebraic expression? Is 1 by x an algebraic expression?
Yes, ma'am.
Yes, ma'am, just X.
Yes, ma'am.
Is 1 by x a polynomial?
No, ma'am.
Why? Why?
Because the degree is 1.
Ma'am, x by 1 by x to the power 1 becomes x to the power minus 1, ma'am. Minus
Very
1
good,
is not
Sanjay.
a real number, ma'am.
Very good, Sanjay. Yes. 1 by x. 1 by x is written as x to the power minus 1. 1 by x is nothing. You should not look at the power of the variable like this when it's in the denominator. You must not look at the power of the variable x when it's in the denominator here. You must take it up to the numerator. 1 by x is nothing but x to the power minus 1. This is how you look at the expression. So 1 by x is nothing but x to the power minus 1. The variable is x. Its power is minus 1. And minus 1 is not a whole number. Minus 1 is not a whole number. And hence 1 by x is not a polynomial. It's an algebraic expression. It's not a polynomial. 1 by x is not a polynomial. It's not a polynomial. Because 1 by x is nothing but x to the power minus 1. The power of the variable x is not a whole number. Whole numbers are 1, 2, 0, 1, 2, 3, 4, and so on. Numbers starting from 0. 0, 1, 2, 3, 4, 5, 6. 0 and all the natural numbers are whole numbers. So minus 1 is not a whole number. Similarly, 1 by x squared is an algebraic expression. It's not a polynomial. Because 1 by x squared is, okay, if it was 2 by x squared, it's 2 into x to the power minus 2. 2 by x squared is nothing but 2 into x to the power minus 2. When you take this up to the numerator, it becomes x to the power minus 2. The power of the variable x is not a whole number. It's not a whole number. It's not 0, 1, or 2, or 3, or 4. It's minus 2. It's not a whole number. So it's not a polynomial. Similarly, 1 by x to the power 100 plus 12 is equal to x to the power 100 plus 12, the whole power minus 1. Now, the simplification of this, we don't have to understand. But you should understand that when you take this up to the numerator, the power, see here, the power is raised to minus 1. This minus 1 will be applied for this also. So here the power of x will go negative, which is not a whole number. And hence, this one is not a polynomial. It's an algebraic expression, but not a polynomial. We are not going into the simplification of this. When you take this up to the numerator, it is x to the power 100 plus 12, the whole power minus 1. So that power will affect the power here, the sign of the power here. So it will go negative, which is not a whole number. And hence, this one is not a polynomial. It is an algebraic expression. It's not a polynomial. So if it is not a polynomial, then you don't have to check its degree and all that. It's not a polynomial at all. So leave that A. Leave the option in A. Which one is a binomial? The heading, the question is, which one is a binomial? If it should be a binomial, it should be a polynomial first. So option A is not a polynomial. So leave that, meaning ignore that option. Now check B. Quickly.
Yes, ma'am. It is a binomial of degree 100.
Ma'am, B is the monomial of degree 100, ma'am.
Yeah. B is a monomial of degree 100. In option B, the degree is 100 because here this is one term, so you'll have to add the powers of the variables. So it will be 50 plus 50, 50 plus 50, 100, 50 plus 50, 100. This is only one term. X is raised to the power 50, Y is also raised to the power 50. There's only one term. So find the sum of the powers, 50 plus 50, 100. So the degree, okay, before that, the powers of the variables are whole numbers. In X to the power 50, Y to the power 50. This one is a polynomial because the powers of the variables are whole numbers. They're all whole numbers. So it is a polynomial. Degree 50 plus 50. 100 is a degree. But it is a monomial. There's only one term. It's a monomial. So as Danya rightly said, option B is a monomial of degree 100. Of degree 100. Second option is a polynomial. It is a polynomial. Because X is the variable, power 50, whole number. Y variable, power 50, whole number. Variables have whole numbers as powers. So this the expression in B is a polynomial. It is a polynomial. This one is a polynomial. But it has only one term. So it's a monomial. But of degree 100. Yeah. Then C. So what are our conclusions so far about A, B, and C? A is not a polynomial. Not a polynomial. A is not a polynomial. B is a monomial. Monomial of degree 100. Of degree 100. What about C, children?
Ma'am, it is a trinomial, ma'am. Yes,
It
ma'am.
is a
Trinomial.
trinomial. C is a trinomial. It's a trinomial of degree
50, ma'am.
50. Of degree 50. In how many variables? In
3 variables, ma'am.
3 variables, X, Y, and Z. In 3 variables, X, Y, and Z. Here, the variable is X, power 25, whole number. Variable Y, power 50, whole number. Variable Z, power 25, whole number. So whole numbers, powers are all whole numbers. So this expression is a polynomial because every variable have whole numbers as their powers. It is a polynomial. And since there are 3 terms, it's a trinomial. It's a trinomial. In this term, the power is 25. In this term, it is 50. In this term, it's 25. The highest power is 50. So the degree is 50. The highest power is 50, so the degree is 50. So C is a trinomial, 3 terms of degree 50 in 3 variables, X, Y, and Z. So it's not a binomial. C is not a binomial. What about D?
Yes, ma'am. D is the answer.
Okay, how do you simplify that?
Ma'am, we're supposed to bring z to the power 12 to the numerator and it becomes z to the power minus 12.
So D can be simplified like this. X to the power 50, Y to the power 48, Z to the power 14 minus 12, correct? Because when bases are same, Z, Z, and its division, we subtract the powers. So 14 minus 12. Exponents, children. Z to the power 14 by Z to the power 12 is equal to Z to the power 14 minus 12. Bases are same, Z, Z. Its division, subtract the powers. 14 minus 12. Minus 12. That other term, minus 12. This is how we simplify. Now, the doubt will be like this, you might think that why you're using the Z to the power 12 only for this one? Why not for X and Y? You cannot see now when you have 24 ABC by 2. This denominator 2, you can use it with 24. If it is 24 by 2, then it's only ABC. This 2 is not for, there's only one term in the numerator. Okay, let me make it like this. You understand it yourself. I'll tell you when it is for all the. Yeah, now see here. If you have a plus b by 2, it is a by 2 plus b by 2. If it is ab by 2, it is only ab by 2. It is not a by 2 into b by 2. See here, I'll just write it here. If it is ab by 2, it is not a by 2 into b by 2. It's not this, because then it will become ab by 4. 2 into 2, 4 it will become. ab by 2 means a by 2 into b, or a into b by 2. ab by 2 is a by 2 into b, or a into b by 2. But when you have a plus b, when you have a plus b by 2, it is a by 2 plus b by 2. LCM is 2, a plus b. So the z, we are simplifying this. We're simplifying this one. Base are same, it's division, we subtract the powers, 14 minus 12. Next, x to the power 50, y to the power 48, z to the power 2, minus 12. So this is only one term. There's only one term. This is the second term. So it's a binomial. It is a binomial. And the degree is 100 because here it is 50. There's only one term. So we'll have to add the powers. 50 plus 48 plus 2, which is 100. 50 plus 48 plus 2 is 100. 50 plus 48 plus 2 is 100. X to the power 50, y to the power 48, z to the power 2 is only one term. So add the powers. 50 plus 48 plus 2 is 100. So option D is a binomial because it has only two terms. It is a binomial of degree 100. Children, any questions?
No, ma'am, it's clear.
No, ma'am.
No, ma'am.
Class, use the emoji. Raise your hand. Lishant and Krishmika Shri. All right. Yeah, any questions, class?
No doubts. ma'am.
Understood, ma'am.
No doubts, ma'am.
All right, children, please write everything. A is not a polynomial. Whatever you see on the screen. Done?
Yes, ma'am.
Yes, ma'am.
1
Yes,
minute.
ma'am.
Yeah. Done, children? Completed. Yeah, the factors of this expression are factorize this, children. A squared minus 1 minus 2x minus x squared. So you can see here, you can see x squared, 2x and 1. So these three terms will make a perfect square. These three terms will make a perfect square. So a squared minus 1 minus 2x minus x squared. Take out minus common and it will become 1 plus 2x plus x squared. So this is nothing but you can just write it the other way also, x squared plus 2x plus 1. So a square minus, this is x plus 1 the whole square. X plus 1 the whole square. Now this is in the form a square minus b square. So a plus b into a minus b. A plus b. A plus b into a minus b into a minus b. So it will be a plus x plus 1 into a minus x minus 1. Option C. See here. Yeah. So here I've just rearranged the terms. I rearranged in here in the second step. In the second, I wrote it here as it is. I rearranged the second step. You can also do this. See here. See here, children. So this expression, you can write it as a square minus x square. Just rearrange the terms. Minus x square minus 2x minus 1. Simply rearrange the terms. This one I've written it here, a square minus x square minus 2x minus 1. Please look at your screen. Take out minus common. Take out minus common, right? A square as it is, take minus common. So in the bracket, you will get x squared plus 2x plus 1. Why? Because when you multiply this minus with all the terms, it will become minus x squared minus 2x minus 1. Taking out minus common. Now this is like a square and this is like b square. And this is 2ab. You can see it here. A the whole square plus b the whole square plus 2 into a into b is nothing but a plus b the whole square. X plus 1 the whole square. Now this is of the form x square minus y square. This one is of the form x square minus y square. X square minus y square. So x square minus y square is x plus y into x minus y. X plus y into x minus y. Okay, so your x is this one, a. Because this is x squared. This is x squared. X squared. This is x squared. You can put a bracket here. Minus y squared. So x is a and y is x plus 1. So x plus y into x minus y. This is x plus y. This is x minus y. Tell you again. This is like x the whole square minus y the whole square. Where x is a and y is x plus 1. So x square minus y square, how do you factorize? X plus y. See here, what is x? This is x. This is y. You can see your x plus y into x minus y. X minus y. X plus y into x minus y. So this becomes a plus x plus 1. Here, apply the minus in, to all the terms in the bracket. So a minus x minus 1. This factorization is of 8th standard, children. So the two factors are a plus x plus 1 and a minus x minus 1. Option C. I'll just come back, children. Please complete this.
Completed, ma'am.
Completed, ma'am.
Completed.
Yeah. Yes, what's the degree of root 5?
1 by 2.
1 by 2, ma'am.
1 by 2.
What's the degree of root 5?
1 by 2.
1 by 2.
1 by 2,
1 by
ma'am.
2, ma'am.
No degree. No degree. That's no variable. That's no x or y.
Hi, Pranjit, earlier you used to keep your video on, no? What
Yes,
happened?
ma'am. I can't in these days. Sorry, ma'am.
Why?
My PC doesn't support cameras, ma'am.
Suddenly?
Yes, ma'am. I used my brother's PC last time.
I can't see many of you. See, I can see Sindhu, Sanjay, always, Tanishka, Netra. Where are the others? Srijana. Srijana, you were not there in the last class, right?
Yes, ma'am.
Yeah.
I
Now
didn't
I
see
can
this
see
meeting
that.
link.
Sorry?
I want to see that recording.
Okay. I think I shared the recording, right?
Yes, ma'am.
Okay. Yeah. Now Krishmika Shri. Devadarshini. Keep your videos turned on, children. All right. Yeah, the degree of root 5. Pranjit again.
There is no degree because there's no x or y variable.
Yeah, so what's your answer? What is the degree of root 5?
0.
0, huh?
1.
1?
I'm not defined.
Not defined.
Or 1 by 2, ma'am.
1 by 2. 0, 1, 1 by 2, not defined. Now settle down with one answer. Class?
No, 1 by 2, ma'am. 1 by
1 by 2.
Ma'am, it's 1 by 2, ma'am.
1 by
Who
2.
decides? Okay, so who decides the degree?
2. The power.
The power of the
Highest power.
variable, right? Okay. Okay, variable. Now is root 5 a variable or a constant?
Constant, ma'am.
Okay. So what kind of a polynomial is root 5?
Constant.
Constant polynomial.
It's a constant polynomial. Root 5 is a constant polynomial. Is 0 a constant polynomial?
No, ma'am. It's a 0 polynomial.
0 polynomial, ma'am.
0 is the 0 polynomial. 0 is not a constant polynomial. 0 is a 0 polynomial. So root 5 is a constant polynomial. Root 5 is a constant polynomial. Okay. Now there is no variable here. So supposing I write x, because I have to understand no degree. Suppose I write x here. I should raise x to the power what?
0, ma'am.
0. Because only if I raise x to the power 0, the value will still be root 5. Root 5 is equal to root 5 x to the any variable x, y, z, any variable, supposing x to the power 0, because I cannot write root 5 as root 5x. That will become root 5x. It's different from root 5. These two are not the same. But if I write root 5x to the power 0, x to the power 0 is 1. So it's still root 5 only. So now what's the variable here? X. What's the power? 0. So what's the degree of root 5?
0, ma'am.
0.
0, ma'am.
Yeah, in general, the degree of a constant polynomial is 0. The degree of a constant polynomial. What is a constant polynomial? All real numbers other than 0. All real numbers other than 0 are constant polynomials. Every real number, that is all rational numbers and irrational numbers, except 0, are called constant polynomials because they're all constants. They all have a fixed value. It's called a constant polynomial because a constant is something that has a fixed value. That's why constant polynomial. But 0 is not a constant polynomial. 0 also is a constant, meaning otherwise, if we don't talk in terms of polynomial, 0 is a constant. 0 is a fixed value. It's a constant, but we don't call it a constant polynomial. All real numbers other than 0 are constant polynomials. And the degree of a constant polynomial is 0 because every constant of 7 you can write it as 7y to the power 0 because y to the power 0 is 1 and 7 into 1 is 7. So y, the variable y is raised to the power 0. So the degree of a constant polynomial is 0. The degree of a constant polynomial is 0. So see, all of you said because root 5 means 5 to the power 1 by 2. So first, all of you said 1 by 2. All of you said 1 by 2 first. You must look for the variable. Where is the variable? Root 5, there is no variable. Root 5 is a constant. So just fix a variable. Raise it to the power 0. So 0, the degree of a constant polynomial is 0. Root 5 is a constant polynomial. Its degree is 0. Yes or no, children?
Yes, ma'am.
Yeah, 1 minute, children. Just yes, children. Yes, children, the degree of minus 100 is?
0, ma'am.
What's the degree of minus 100?
0.
Zero, ma'am.
What is minus 100? It's a constant polynomial, right?
Constant polynomial, ma'am.
It's a constant polynomial. So its
Yes, ma'am.
degree is 0. What's the degree of 0?
Not defined, ma'am.
Not defined,
Because, yeah, because you cannot give one answer. Because you can write 0 in many ways. You can write 0 as 0x squared. You can write 0 as 0y to the power 100. Because all this is 0 only. 0x squared is also 0. 0y to the power 100 is 0. Because it's y to the power 100 into 0. 0 0 y to the power 100 means what? 0 into y to the power 100. So it's 0. So each one of you will tell me a different answer. But degree of a polynomial is one answer. The answer should be unique. That's why we say the degree of 0 is not defined. The degree of 0 is not defined. Is not defined. What about the degree of this expression?
1, ma'am.
1, ma'am. 1.
1. So is it a linear polynomial?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
It is a linear polynomial. In how many variables? A, B, C, D, and E. 5 variables.
5.
It's a linear polynomial. It's a linear polynomial. You should not add the powers. Power is 1 everywhere, but you should not add the powers. They are different terms. This is one term. The power is 1. This is the second term. It's a different term. Power 1. This is a different term. Power 1. Different term. This is also a different term. If within one term you have many variables, you should add the powers. Within one term, if you have many variables, you should add the powers. These are all different terms. The powers are 1 everywhere. The highest power is 1, so the degree is 1. You must have written the statements. Fill the answers quickly.
Completed, ma'am.
Yeah.
Completed, ma'am.
Yeah. Yes. Is this expression a cubic polynomial? Quickly simplify, if possible.
Yes, ma'am. It is a cubic polynomial.
Yes, Tanishka, tell me your steps. Yeah, Tanishka.
Ma'am, her mic is muted.
Oh, she's. I thought she is. Tanishka,
now can you hear?
Yeah. Okay. Yes, Tanishka, tell me.
And 5y power 7 by 2 minus 11y power 3 by 2 minus y 1 by 2 minus 1 by 2, ma'am. That 1 by 2 minus 1 by 2 cancel. So 5y power 7 by 2 minus 11y power 3 by 2 minus 1, ma'am.
Okay.
Y power 0 is 1, ma'am.
Correct.
So it's a cubic polynomial, ma'am.
Because there are 3 terms, huh?
Yes, ma'am. Oh,
If there are 3 terms, it's a trinomial.
one minute, ma'am.
The degree decides whether it's a cubic polynomial or right, no, ma'am?
Yeah, correct. How do we simplify this? See, children, that's what there's a lot of things you will understand from, the questions we're discussing today. So earlier we had a situation where it was x to the power whatever. I'll just take a different power, y to the power 7 and z to the power 14 by z to the power 7. Now when it's multiplication, z to the power 7 will be used with this one, or this one. See, please understand from this, a, b, c by 2 means a by 2 into bc, or it is b by 2 into ac, or it is c by 2 into ab. It is not a by 2 into b by 2 into c by 2. It is not. Because that will become abc by 8. 2 is applied only. If you say a by 2, then it is into bc. But if you have a plus b plus c by 2, this is a by 2 plus b by 2 plus c by 2. We apply that to every term. These are 3 different terms. But when I write ABC by 2, there's only one term. A plus B plus C by 2 means A by 2 plus B by 2 plus C by 2. But ABC by 2 will be A by 2 into BC, or it will be B by 2 into AC, or it will be C by 2 into AB. So here this will be 5 to the power y, 5y to the power 7 by 2 by y to the power 1 by 2, because square root of y means y to the power 1 by 2, minus 11y to the power 3 by 2 by y to the power 1 by 2 minus y to the power 1 by 2 by y to the power 1 by 2. I'll show you the working here. See here. Yeah. So these are the terms in the numerator divided by y to the power 1 by 2, because root y is 1 by 2. Then this is what I just wrote. Every term in the numerator is divided by y to the power 1 by 2. Every term in the numerator is divided by y to the power 1 by 2. That's the second step. Then when bases are same and its division, we subtract the powers. So 7 by 2 minus 1 by 2, 3 by 2 minus 1 by 2, 1 by 2 minus 1 by 2. So 7 minus 1 is 6. 6 by 2 is 3. 7 minus 1 is 6. 6 by 2 is 3. 3 minus 1 is 2. 2 by 2 is 1. And half minus half is 0. Simplified. So it's 5y cubed minus 11y minus 1. Y to the power 0 is 1. So the given expression is a cubic polynomial, because you can see the variable y power 3, variable y power 1, highest power is 3. So it's a cubic polynomial. The highest power is 3, it's a cubic polynomial. It's a trinomial. Based on number of terms, it's a trinomial. Degree is 3, so it's a cubic polynomial. Take a screenshot, children, and complete this. I think we have 4 more. I want to finish this today.
Taken.
Yeah, take a picture. Please complete it after the class. Don't forget. Very important. Yeah, the number of terms of the polynomial. How many terms are there?
3, ma'am.
3, ma'am.
3.
3, ma'am.
3. 1, 2, 3 terms. So the number of terms of the polynomial, this one is 3. Take a picture, children. Done?
Yes, ma'am.
Which one of the following are non-negative integers? Which one of the following are non-negative?
Show that slide 1 second.
Yeah.
Taken, thank you.
Yeah. Which one of the following are non-negative integers?
D. Option D.
D, yeah?
Yes, ma'am.
Option D, ma'am.
D.
D, ma'am.
So that means you people are just attending the classes. You're not doing any homework.
Ma'am, I think except for B, everything is non-negative.
Integers.
Yes, ma'am.
Okay. Sorry?
Ma'am, it's 13 the answer, ma'am.
Only 13, huh?
Ma'am,
I
zero
think
on the-
4 by 5 also.
Okay, let me write out the integers first. Okay, so just tell me if I'm right. -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. Am I right? Is this the collection of integers?
Yes, ma'am.
Yes, ma'am.
What do you mean by non-negative? It should not be negative, correct?
Yes, ma'am.
Yes, ma'am.
So I'll take away all the negative integers, correct?
Yes, ma'am.
So these are non-negative. All these are non-negative. All these are non-negative. That means whole numbers. Whole numbers. 1 minute, children. Sorry, children. A lot of many times I had to excuse myself. Sorry. So see here the collection of integers, children. -3, -2, -1, 0, 1, 2, 3, and so on. Collection of integers. Yeah, children. So take away all the, see, non-negative meaning they should not be negative, non-negative. So let me remove all the negative integers. These are all negative. So all these are non-negative integers. So what are they? Whole numbers. Whole numbers. Non-negative integers means whole numbers. Non-negative integers means whole numbers. Remember that. Means whole numbers. So which are the whole numbers here? 0 is a whole number, 13 is a whole number. So C and D. C and D. This is not a whole number. This is also not a whole number. This is a whole number, this is a whole number. Take a picture.
Done, ma'am.
Yeah, this
I'm
one.
1 minute so again, ma'am.
Yeah.
Thank you,
Done?
ma'am.
Now this one. Is it a binomial?
Yes, ma'am. Yes, ma'am.
Is it a polynomial of degree 4?
No, ma'am.
No, ma'am. No, ma'am.
Yes, ma'am. Yes, ma'am. Yes, ma'am. Sorry,
Yes,
yes, ma'am.
ma'am.
Yes, ma'am. Yes, ma'am. Yes, ma'am.
3, 4, ma'am.
PQ 2 plus 1 plus 1, 4.
Is it an algebraic expression?
Yes, ma'am.
Yes,
Yes, ma'am.
So then what's the correct option?
D.
All of A, B, C, ma'am.
All of A, B, and C. All of A, B, and C. Because this one is a binomial. It has two terms. So it is a binomial. It is a polynomial of degree 4 because in this term here, see 16 is a constant. Leave that. The variables are here. P square QR. So 2 plus 1 plus 1. Because the power is 1 here. Power is 1 here. So 2 plus 1 plus 1. 4. So it is a polynomial of degree 4. And it is definitely an algebraic expression. It is a binomial. It is a polynomial of degree 4. It is an algebraic expression. So all of A, B, and C. All of A, B, and C.
Taken, ma'am.
Children, please complete this soon after the class. Yeah. Every algebraic expression is a polynomial. True or false?
I think false.
False.
False, false, false.
False, ma'am.
Is the converse true? Every polynomial is an algebraic expression?
Yes,
Yes,
ma'am.
ma'am.
That is
Yes,
true.
ma'am.
Yeah, every polynomial is an algebraic expression. But every algebraic expression need not be a polynomial. Every algebraic expression may not be a polynomial. All right, children. That's it for today's session. Thank you so much. You may leave the
Thank you,
call.
ma'am. Thank you, ma'am.
Please complete your classwork.
Thank you, ma'am.
Yes,
Thank you,
ma'am.
Thank you.
Thank you, ma'am.
Thank you. Thank you, children.